There we go. Class 10, I think it is the 12th today. The day after the Chiefs won the Super Bowl. Got to throw that out there for all the Kansas City people. Kids get off school on Wednesday because of it. So there are 3 chapters that we get to go over. The first 2 were like one pager, half page things. And then the main topics that we'll talk about is exceptions. So scope, they brought this back. We've talked about scope a little bit. During the live coding, I'll explain a little bit more of this and show you some examples, but they have what they call local or block scope, global scope, which is the whole entire file. They talked about variable shadowing and variable hoisting. They didn't talk about redeclaration, but as I was doing things, I think that was where some people were also having some thoughts. So I'm going to show all of that during live coding. I think based on the definition, most people understood those by definition, but then they wanted just more core examples to work through them. So we'll do that. Chapter 16, data types. I don't know why they either didn't include this at the beginning or they just don't include it somewhere else. But they added some primitive data types for us called undefined and null. So we've talked about strings, numbers, booleans, but now they have undefined and null. And that was about it for the chapter. So pretty easy chapters. Exceptions, here we go. So exceptions, when I'm always trying to tier these off for like, if you get a job as an entry-level person, how much do you need to know about these versus how well do you have to actually interact with these? And this is one that you absolutely need to know what it is because there will be code around this, but most of the code will already be set up for you. As an entry-level dev, you're probably not going to write a lot of stuff with using try-catch. It's mainly dealing with stuff that they've already written, or a senior might write some of it and then you have to like fill in some gaps or something, but you're not gonna probably be asked to do a lot of this stuff day one on the job. On the other hand, if they talk about it, you need to know what the vocabulary that they're using is. So exceptions, we've already talked about some of these exceptions. There's like a syntax error exception, a reference error, a type error. Those are the ones that they brought up in the book. There are more than these. But we have talked about those in debugging. So whenever we usually hit one of these exceptions, it actually stops our program. So the times that we are wanting to use the try catch is whenever we do not want to just stop our program. So what we want to do is, if we understand that there's an exception, it's okay if we just keep going. So that's when we use a try catch, is when we know whatever we're going to do, we're just going to keep on going. Whenever we do run into an exception, it throws what they call an error. And this error is not just like a message. It's an object that we can handle. We can do name and messages. So the name would be like syntax error. The name would be reference error, etc. And then the message usually includes our stack trace in it. And that helps us whenever we're going through it to like debug it and figure out what else is going on. So we can actually call these. So during the live stuff, I'll actually call it by name so that you can see that. Whenever we're throwing errors, because at some point we want to like catch something, but because we know why it's there, we're going to say, instead of you throwing the error, why don't I throw the error and I can write a custom message in there so that whenever it actually bubbles up, I know what it's even talking about. So usually we write kind of custom, even if it's messages, but then we can write them to pre-existing exceptions or the default error. And then the format, the structure is we make this try block and we put all of our code that we want to try. If we are expecting an exception to be thrown, we put it in a try block, and then we write a catch block that actually catches it. And then the finally is to get it so that even if it throws an error or doesn't throw an error, you'll still be able to run that section of code. Oh, that was not supposed to, that was it for the live coding. Until the live coding. Right. Like I said, not a huge amount of stuff in there. Most of this will be showing you examples. Right. This is about scope. So nothing about error exception, kind of going in order of the textbook. This is an interesting one where I haven't done const, but I'm hoping you guys understand that const, the big thing there is once you set it, you cannot reset it. So that's why I'm not doing const here. Const and let with scope, const and let have the same scope qualities. So if I use let or I use const, it'll have the same scope type. Okay. The other thing that I want to make sure that you guys are good with, if you aren't using this either prettier formatter or some kind of formatter, I would highly suggest it because it'll help you with the scope. That's how I'm going to explain this. If you look at the indentation level, that's what they mean by blocks. So if I go over here and this function and I close it, this function is in a block. So if I declare a variable anywhere on now my line 2, if I declare anything up here, it is accessible inside this function, but not outside the function. And visually, that what I try to tell people is your function indents right here. So anything on this and inward will work. Whenever you put another block, like an if block there, anything inside this if, depending on what type it is, may not be visible outside the if statement. So this if is considered a block of code. And how do I know that? If you're using a prettier format, if it's indented, it doesn't always go outside. So that's the easiest way to kind of talk about scope. So JavaScript used to use var for everything. Let did not even come into existence until about 2015. But the reason it came into existence is people were using var everywhere, and then scopes were overlapping and causing lots of chaos. Nobody knew where their variables were made accessible at. So they came up with let, and they said let has a very defined scope. If I use let, it is only accessible in this block of code, and it's only accessible after I assign it. So y is only accessible on line 4 and line 5, but as soon as I have this in curly brace, y is no longer accessible. It's very well defined. Var, on the other hand, I still don't know all of the limitations of this, but I think if you declare a var inside of a function, it'll at least stay inside this function. But that's what we're going to test out right here. We're gonna have some fun right here. Let me move this panel to the right, and let me clear this out. Okay, we're going to do some things, and we're going to see what. So var x is assigned here. Are we good that true is always going to evaluate? So this if block is just to put a block in there. It's not actually testing anything. It's just saying, hey, make an extra block so that we can mess with this scope. Right here, we're going to call example, and it's going to call this. It's going to go through here. You're going to see the console logs. but I also want to make sure that we can see these on the outside as well, so you can see what gets. Okay. Then we know that X is always 10, Y is always 20, Z is always 30. This will cause an error. Node. It says Y is not defined on line 8. So right here, even though Y is assigned right here and I'm calling it right here and it's inside the function, this let only works inside this if statement. So I'm just kind of proving to you what I showed you earlier. So I'm going to comment this line out and see if I get any more errors. My next error is on line 13. So what did print is 10 printed here and 30 printed here. What that means is the var is not only assigned inside the if statement, it can go outside the if statement. The Z is the same way, it can go outside the if statement. So the 10 and 30 worked, but when I got down here, when it said X, that's when it threw the error. It said it didn't know what X was. So even though the var was able to go outside the if statement, it does not go outside the function. So I know that's going to error and this is going to error. Let's see if Z errors. Oh, do I have something else? Line 160. Well, that's going to mess up our code up here. All right. Let me run this again. So the X is inside the function, but outside the if statement. But this Z, I can access this Z clear on the outside. So for those of you that were asking, when it says you don't use anything like a let or a var, it assigns it globally. Globally means it can be accessed on any indentation level that we have. So it can be accessed clear at the base index level, at the base of the file. Yeah, so if you don't use any of them, it turns it into a global. So here's a couple just thoughts, not that right or wrong per se, but typically if you're going to set a global variable, you're going to use a let, and you're going to assign it globally, means on the first, like no indent outside of the function. This is what I would expect. This does the same thing. It'll still run just fine with no errors. I just explicitly said Z is a global variable because I'm telling everybody right here that Z is a global variable. This is good coding practice. Doing this is horrible because when we talk about shadowing, which is also not the best practice, I don't know which Z it's talking about because Z got assigned here, but I could have assigned a Z in a different function. And if I didn't put the let, this one would not have got erased as it went outside the function or forgotten. That's how I think about it. You know, there's short-term memory and long-term memory. Your global variables are your long-term memory. It remembers it through the whole file, but your short-term memory only handles it inside the function. And once it gets outside that function, all those variables get wiped away. So global variables you need to assign outside to ensure that they are read by everybody as this is a global variable, or else I would have just skimming through this missed that that was a global variable. I would not have caught that if I was reading this code, because that's what I'm looking for. And the same thing is with var. var, because it could be inside or outside of any block, it's kind of inconsistent. This is not very common practice either. The most common practice is at the beginning of a file or right before you use something, you can assign the variable either with just declaring it or declaring it and initializing it. It doesn't matter which one, but you're going to do that at the scope you want. And so here, if I want any of these these should technically be declared here. So whenever you use a function, if you see me write functions, usually the first thing I'm thinking about is what variables am I going to use in this function? And then how am I going to use them? And that should be very, very logical for most people, is which variables am I going to use? How am I going to use them? If I don't know how I'm going to use them, you can just say, hey, I am going to use this variable, but then actually assign it later. That's fine. But you're at least declaring it. And again, I think common practice is to always use either let or const, not var. I'm going to read through the questions real quick to see. Okay, so some questions here. I'm trying to combine all of these, so I'm answering all the questions the best that I can. If you do not declare a variable such as z or x, let's just get rid of those. I'm only declaring y right here. These, if I don't put let or const in front of this and there's no other let or const anywhere to here, these become global variables, and I can now access them outside of here. So this x and z, I'm doing right here and right here, which is inside the function, which kind of makes sense, but it is also running right here, x and z. That's why I'm seeing the 10 twice and the 30 twice, because I'm seeing it once on the inside and once on the outside. So if you do not put let or const, and it has never been declared anywhere else, it will automatically think it's a global variable. I'm not saying that that's good practice. That's actually very bad practice. But JavaScript can do several things that I consider bad practice. In Java, this never happens. In Java, you can't do this. So somebody said, like, what if you want user input? So scope isn't one of those things where if you have user input, there's only one right way to do it, as much as you need to know when and how you're going to use that user input, and then decide from there, do you want to declare it as global or not? It is perfectly fine. Let's say that I want to grab the user input inside here, but I want to use it in several different places. I can go ahead and set let user input and just say, hey, this is a variable. I'm not declaring it right now. I'm going to use it. But when I use it, I want everybody to be able to use this. So I would declare it up here. I would initialize it somewhere in here. And of course, I don't have anything. I don't have any node modules or anything. So just know that that's not good syntax or whatever else. But I could declare it up here, actually initialize it in here, and then in a separate function, use it somewhere else. That's perfectly acceptable. I'm declaring outside, using it in multiple places. The hard part for me sometimes, so JavaScript, because of the weird space it is in with mainly front-end development, it fits a lot of different tight spaces and what it needs. It's more of a scripting language, which is a small script like this, where, what I develop in with Java being object-oriented, whenever we do classes, you will start to see the inside of how I view things, because I view everything through a class or an object. That's just how I view everything. So this, I'm like, why would I even do this? Well, I would usually attach this to an object and then create an object or create like the game, whenever you guys were creating the Scrabble game, that game would be an object, and then I would have methods inside there, and I would have a constructor that would create this game and then run the methods and stuff inside of it. That should not, if you've never done programming before, that will not make sense to you at all. But that's how I view things, and that's how I program, is I create objects and classes and then methods to do what I want on the objects. So it's slightly different thought process than what we're doing here. That's why some of your questions of scope is a little bit different once you get into objects. Yeah, the name one I think is in here. I just copied and pasted it, so I'm gonna go over the name example here, because that'll also go over shadowing and stuff. But I don't mind coming back to this if people have questions. This was my big one of like just copying and pasting and showing where it prints out and where it doesn't print out. Oh, the other thing that I wanted to show. So again, I can go back later, but let's keep moving forward. What I have here, I think this is from the book. Yeah, this is from the book. What this does is it just has A, B. A is visible here. You can see A inside here because remember, A is technically a global variable because it's initialized outside of everything. B, as soon as it returns here, B gets forgotten. So if I wanted to use B down here, I couldn't do it. If I wanted to use B down here, I couldn't. So B can only be used inside this function. And the same thing with C. C can only be used inside this function. But A can be used everywhere because it's global. And I usually look at the index. Not index, indentation. When I look at the indentation, if I know that let is indented because it's inside a function, then I know this let cannot be viewed out here. What I wanted to show different. So let's change our mindset a little bit. Whenever things get called, this is hopefully going to prep us into the exceptions. There's what we call a stack trace that gets created. So I want to show that to you by running my little debugger. So I've been learning. If I go to this debugging thing off to the left, there's one called JavaScript Debugging Terminal. It reopens up a terminal, but it has this little bugger, this little bug next to it. And I just treat it like my normal terminal. So the question, does indenting matter? JavaScript does not care about indenting. So I can indent this all I want to. It doesn't matter. The reason I say indenting is whenever I do my Alt-Shift-F to prettier, it's going to auto-correct me to not be indented. So I keep saying that as a visual reference, but it's not truly accurate whenever you're talking about JavaScript. Now, Python, this is one reason why I like Python. Python does indenting. So if I'm writing a cool function in Python, I actually get rid of these and I indent this. So if I did this, Python would throw a fit. If I did this, Python would love it. So Python does indenting as its closure. I think that's what it's called. So it knows that it's at the end of a function whenever the next line is not indented. Anyway, Python's different. Debugging. I get easily sidetracked. All right, so I'm going to run this, but I am going to set a breakpoint inside this cool function right here. And again, what I did, I went over here to run and debug. I saw this JavaScript debug terminal. When it did it, it opened up a new terminal that gave me a little bug icon. And then I'm just running it like I normally do, but it'll run it with the debugger and it'll stop at these breakpoints. So whenever I do this, it says, oh, you set a breakpoint on line 27. What are you doing there? If you look over here, it's called a call stack. So this is your call stack. JavaScript, this is not just JavaScript. Every programming language has all of these other things that are running behind the scenes. This will always happen. They're grayed out because they don't matter to us as a programmer. So they kind of helped us out by graying them out. This anonymous function is technically line 37. I don't know if you can, it's, here, I'll try to make it a little bit bigger. It says line 37 right here. It says anonymous line 37. So if I go to line 37, what it's saying is my console log called something. And then it says on the next thing up, it says line 27. So line 27 is where I'm at right now. And it is inside this cool function. So this, it actually knows the name of it. It's called global, meaning it can be accessed anywhere, which is the function is a global function called cool function. And that's where I'm at right now. Anonymous, remember, is this console log. I didn't name it. It's technically an unnamed function that's going on right here. When I say keep going, it's going to do it again. But this time over here, it says it's line 38. It's anonymous line 38. Well, line 38 calls the cooler function. And the cooler function, it says here on line 33. So on line 33, it calls the cool function. That's what this line here is, calling line 33, calling cool function, which then gets me where I'm at right now, which is line 27, which is B. So it is showing you here that what it does is it keeps stacking things on top until it can go backwards. So once this gets done, so I'm going to hit next line, step over. Once this gets done, you'll see over here, it changes just slightly. The first thing is it changes to line 28. And it just collapsed the cool function. Now it's just at the cooler function on line 34. So the stack trace, what it did was whenever it got to line 33, it says, oh, I need to open up another tab, another function. So I'm actually open. Both functions earlier were open. Cooler function and cool function were open at the same time. That means all the resources needed for both of those have to be accessible to the computer. Now, for these functions only being a couple lines long with a couple variables, that doesn't really matter. But the whole reason some of these scope things matter is, let's say I have a function that calls another object, which then calls another function that calls another function somewhere else, that calls some built-in function that then needs memory for something. Well, I can't get rid of the memory that I'm already being used. So all of that stuff starts expanding the resources needed to write that, for that program to run at that given time. And so the program knows that. So as soon as it gets done with this cool function, so as soon as it returns this, as you can see here, there's no more cool function in its properties over here. It does not care about cool function anymore. It actually just wipes A and, well, not A because it's global, but it wipes B out of its system. And so if I go up here, and of course I don't know how to, oh, there it is. If I go up here, I can find C and A, but no more can I actually find B. B is gone. And that's an important computer science topic. That is not going to make you an excellent programmer, always thinking about those small things. But when you get to that mid and senior level, what they're doing is they're trying to get you to write more efficient code, right? So again, I'll always go back to the first job is to get code that works. And then you refactor to get better code. At your stage of the game, you're just caring about getting code that works. And then you're slowly trying to develop more skills, more tools for your toolbox to get better code. And this is how you would do that. understanding that sometimes you want things to be locally scoped so that once this function is done, it can forget about those variables because I don't need those variables anywhere else. It's a very big topic that you'll kind of be talked through potentially on an interview or something like that. They would potentially talk to you about local versus global scope. Why would you use one versus the other? Easy concept is global scope is whenever multiple things need to access it, multiple functions. If you only need it for one function or one little piece, you try to locally scope it because it will erase it from the resources once it's not being used. Fine. So real quick, I'm going off task just slightly. What I do is I had to reinstall it just today. I installed this code formatter called Prettier. I used to have Prettier Now. I don't know why, but I installed it so long ago I can't remember. But I guess it got deprecated, so I had to do the Prettier here. I think I might have used this one before. I can't remember. Anyway, this Prettier format, and you can use multiple ones. You don't have to use this one. There's some that are very language specific. So like I bet you these Golang tools have like Prettier. It's not called Prettier, but it's code formatting. You can do whatever you want to there. I use Prettier because it's very generic, but it does pretty good job for almost everything I'm doing. When you do Control-Shift-F, that's this one. It's format document. That's the action that's called. Format document indents everything for you, and it like restructures your text so that it looks better for programming. You don't have to use it. Your code will still run without it, but I do it all the time. The first thing I'll have some of you have seen this live. Whenever I look at your code, I'm like, that doesn't look right. Do the Alt-Shift-F. If you're on a Mac, it's Command-Shift-F. No, it's not. It's OPT Shift F. Sorry. So on Mac, it's Shift F. And so whenever you do that, it should prompt you the first time of like, hey, what formatter do you want to use? But then once you pick one, it'll use that one every time. And I picked Prettier. That's why you don't see the option up there. It's just a built-in tool to VS Code. No, a stack is a stack. Different, like VS Code versus IntelliJ might call them different, but a stack is a stack. You're just stacking processes on top of each other, and then you're trying to hopefully back out of them and return what you want to the level underneath. I'm gonna keep going. If you need it, just keep the questions flowing if you want. Fine. Debugger. I think this is the name one. Let me get my screen looking a little bit better. Because I don't want to have to worry about entering in my name, I'm just going to hard code this, but I think most of you will get the idea here. So I'm not going to need the input here because I'm not going to do that. So just to refresh us, there's a function called hello that's going to say hello, and whatever the name is passed in here is going to be here. It's going to reset the name to be Ruth, and then it's going to call double name with Ruth. And so Ruth is going to get passed in, and it's going to say Ruth, but then it's going to return root to here, which is then going to return it to this one. Oh yeah, and name is deprecated, so that's not confusing at all. But then, yeah, let's run this and see. Oh, I did not want to run the debugger. There should be no breakpoints. Nope. Right. So it says here, hello, Philip. So if we go in name, it says hello name. So it says hello, Philip. Actually, let's use the debugger. Why not? This is why we have it here. All right, so as we go through here, and I'm not gonna, you can look up, this is a little bit small. That's a little big. Hold on. Let me see if I can, let's see if this isn't too confusing for you. All right. So right now, I'm on line 45. I can tell that by this yellow arrow. I'm on line 45, and it says that my name is Philip. So whenever it prints out hello name right down here, it should say hello Philip. Let's see if I'm right. Yep, hello Philip. This thing means next line, so I'm just going to go line by line. It's going to set my name to Ruth. So if you see here, it says name is Ruth. So whenever I go next line, it still has my name is Ruth. So it's going to print me Ruth, Ruth. It's going to return Ruth, Ruth back to here. You see how it jumped back to 47. 47 says return whatever you have here, which is Ruth, Ruth, but we're going to return it to right here, which this is not a console log. So it's not going to print it. So this line, I didn't accept the return, but right here is technically Ruth, Ruth. And then it goes double name, but I put in the name. But do you see how the name is Philip? Because the global name, Ruth was just the local name. It only stayed inside this function. The only reason it went inside this function is because I passed the name into that function. That's the only reason it went in there. I did not reset anything. I'm going to go a little faster. And then whenever I do console log my name is still Philip because it never got changed. So. Okay, so good question. I'm glad you actually said this. I'm going to talk about that. I'm just trying to also read. So another good question, where do you set breakpoints? If you setting a breakpoint on the actual name of the function, it does not execute this line. So you usually don't set a breakpoint except on lines that are executed. So this line is not executed. This is the first line of the function. So you always set it one line in to the function if you want to run the function for the breakpoints. But okay, so a good question here. This name does not say, this thing does not say var or let or any of those things. How did it know what to do here? And remember up above, I had that letter Z, and Z became global. I mean, that's the kind of craziness that's going on that could potentially go on here. So this name could be global, but it's not because it was established, and this variable here was established right here in the function. So whenever I pass in a parameter here, it's almost like a let or a var right here, and it does not become global. Let me do this. All right. So this one is not like my Z, because by the time it's gotten to here, it already has seen this variable before. So it kind of checks, hey, do I know what this variable is? Yes. Okay, I'm going to use that one. Kind of like putting this, but sure. We will do this when we get to objects. Okay. Yeah, this parameter right here is the reason why all of these are taken from the same memory space as this one. Yeah, so it was declared Philip, and then right here redeclared Ruth, but this did not redeclare my global name. It redefined my local name to be Ruth, because local names cannot override global variables. You can use const on almost any parameter as long as it doesn't change. I think this one would be fine to do. Maybe, I don't know. That's why I just kind of, nope. So it says name has already been declared, and that's because it's the name that's on line 44. This name has already been declared, so I can't use const there. I technically, yeah, I can't use that in a. I've done too many other languages where I could set the const inside there, but JavaScript doesn't let me. But play with that on your own. I think I've gotten what I need. Okay. This is just to reiterate the scope things. So let me clear this for a second. So what I did here is I had a global A, and then I set a local A, and then the inside A is the 10. And even though I returned A here, my outside A is still 0. So that's why I said inside is 10, outside is 0. Now, the question is, if I get rid of this let, how does that change things? And it actually sets the global variable. Isn't that the most confusing thing? Because up above, we were setting name and it did not reset it. But here we did reset it. This is why scope matters. And this is why I like to stick in my world of Java where this never happens. So, yeah. I don't know about never, but yeah. So if I say let, it is redeclaring a separate variable. And I can do this if they're not in the same scope. So this is global scope, this is local scope. So the compiler is allowing me to do that. If I don't do let, when it hits this A, it assumes A is here. So it assumes these are the same variable. I think the difference before is if I did something like this. Let's see what this does. Yeah, that's what I was thinking. So if I say, hey, my function is going to use this local variable A, then whenever I use it here, it uses it as a local variable and uses the 10, but it does not set the outside one. So this is just like saying let A. It doesn't declare it all the time, but this is using a let A. brain's becoming a little bit of mush. So I am not going to go over in too much detail. I know I said I'd go over a little bit, but I think the bigger part is the why more than the how on this try catch stuff. So here's some whys, and of course I got this from ChatGPT, favorite source whenever you guys ask me questions and I don't know the answer to. The question was, why and how would I use try catch and maybe even finally in the real world? And I will tell you an example of how I spent a whole month redefining our try catch stuff in Golang in one of our services. And so I will tell you what and how and why I did all of that. I'm not going to show you code though, but I'll tell you the how and why. But these are small ones that I think you can wrap your mind around pretty quickly. Let's say that I wanted to go inside of a file and grab content out of it. This is something that scripts do all the time. I've written something like this in Python, I don't know how many times. I grab CSV files, take the information inside of it, and then I look at column 2 because that's a date, and I do something based on the date. It doesn't matter what I'm doing. I'm trying to gather information in, look at a file, and do something based on it. I would 100% use a try catch on that. And the reason why, whenever I read a file, oftentimes I'm going to read it line by line. And you can't tell me that when you're reading a file line by line that there isn't going to be some inconsistencies in there somewhere. Well, because there's an inconsistency on line 5, I don't want it to stop. I want it to like log that line 5 is odd, so go look at it manually, but then I want you to keep going. And that is a perfect time for a try catch, because I'm going to try all the lines that I can. When I hit a line, now in my opinion, like what I was describing on line by line, this would be in a while loop and doing try catch in a while loop, because it'd be while the first line, try the first line. If the first line's good, keep going. At the end, like if you ever catch an error, throw the error. But if you remember, anytime you hit an error, it stops the code. Have you guys ever, like in your graded assignments, when it hits an error, it just stops? Well, you don't want it to stop when you're reading through all these lines of code. So you want it to do something else. You are handling that workflow to go do something else. And I could just spit out an error message in my log to have me go look at it later, but it takes care of all the lines that I care about. If I was using that example, whenever you do a file read, oftentimes you have to close that file or do some kind of cleanup with that file. So you can use maybe a finally for that. So that's one example. This is the same thing, but instead of with a file, it's with a fetch data from a URL. So let's say that you guys, actually, by the end of this chapter, you might actually want to do something similar to this, where you're going to hopefully go to, I'm making up what you're actually going to do, but maybe you want to go to the Weather API app and say, hey, weather.com, what's the weather today and tomorrow? And then they tell you, and then you create like a user interface for that. Well, what if the information they give you changes? What if you look for a day of like the 31st, but not every day has a 31st? What if, all those exceptions that could potentially happen? What if you call it and it's down right this second? Do you want it to just stop and break everything? Or do you want it to just keep trying the best that it can and just send you error messages that you throw into a log and see later? So this would be, you're going to await their response. They're going to log the data. But if at any point in here, there's an error. So let's say that you actually go try to fetch it and you're trying to wait for the response and the response never happens. It could do this, and it'll just say error fetching data, and it'll tell you the message. So another example, just like and that's what it's saying, fetch data from this API example.com/data. So that's where it would try to go. Just like these other ones, I know these are very similar, but I'm just kind of throwing these at you. What if I'm reading from a database? So I actually am doing this right now. At my job, I'm creating a login script where it calls a database to see if a client has ever been registered in our Salesforce system. And sometimes they're not in our system. So what I do is I say, hey, try to go find that user and use this. This is a SQL command, a valid SQL command. Select all. This is a wildcard. Select all from users where .id equals, and then you can throw in. So this question mark. How this works is this question mark gets replaced with the user ID that gets sent in. So this looks very similar to something that I would write. And what if it comes back with this user, it doesn't exist? Well, this query might, depending on how you do it, throw an error saying, this is a bad query because the user ID doesn't exist. So you're going to send this error. But let's say that I want to run through this several times. I don't want my program just to stop. I want it to try the query. If there's a problem, you're going to write an error. But do you see how there's no, I guess the other thing I should have been pointing out, these aren't throwing any other errors. That's a key point. They're not throwing any errors because these are expected behaviors. I expect that my database is not going to have every user ID in it. So I don't want it to just stop my whole process. I'm going to log that error that user didn't exist, and then I'm going to keep going. I'm not going to undo all of these, but parsing a number. So let's say that, you have a number. Now this one does throw an exception. So maybe I will uncomment this for a second, just so you can see. What this says is, hey, parse this input. This input puts it into a float. It asks, is it not a number? And if it is not a number, it's going to throw. You're forcing this error, but it's a common error. Like it's a custom error, but that doesn't bubble up and stop everything. Because right here, you're going to catch that error. So right here, you're going to throw an error. Right here, you're going to catch it. You're going to say error parsing number, and this message is going to say invalid number format. So this is going to read this message. And you can always use a finally at some point. Yeah, so the good question is, finally runs every single time. It doesn't always do it when it's right or wrong. So the question was, how do I know that it actually ran correctly? And that's technically, if it runs this last line, then it ran correctly. So I could easily put a console log this ran correctly. I mean, I could technically do that right here because I know that this is not going to throw an error. And this will only get ran if it actually ran correctly, because the only time it's going to throw an error is up here. I don't know if in JavaScript you need this new. So in Java, you need to have this new in here, because if you don't say new, then it's assuming that there's an error already and you're modifying it, where new says, here's a new error, I'm not modifying it, this is a new one. That's what the new keyword should be doing. On the other hand, as you've seen, you don't always have to put let or const in front of a variable. You can just declare it, and JavaScript works. So I cannot tell you definitively right this second if you need this, but this is absolutely a good programming to say through new error. If you don't throw your own error, the program will return the error code. That would stop the program without a try catch. So I think what you're saying is if there was an error in here that like let's say there was a runtime error normally, and I don't put it in the try catch, obviously it's going to throw an error if we expect that. If I do the try catch and I say throw error, you're asking if it'll throw the same error type, where this would be another message as well. I don't think so. I think this new should be here. Instead of error, there are different types of errors. So is there a type? Yeah, type error. I think there's a reference error. So this declares the error type that I'm going to throw. I don't think the new does anything really, except I think that you should have new every time. End users almost never see these errors, so definitely not for end users. So Ron, I don't know if this makes sense. Like this is your error.name, and this is your error.message. And so this would just be a regular error where I can tell it what this is, a type error, a reference error. That's what I'm throwing. And comment this out. It's actually going a little bit longer than I thought, which is good. Hopefully we're learning some things. Here's another prompt one. I'm not going to do this one, but you can throw different errors. You know how we were just putting it in a while loop and keep going? There are different ways to use throw and catch here. So what I wanted to do is just go over some brief things here. I'm going to say let answer equal 5, then answer equal this. But as of right now, this line will not run. So if you saw here, I purposely did not install the input, the read line sync. I'm purposely throwing an error. It says that this is a reference error because input is not defined. So I kind of purposely did that. Let's just kind of show you what I'm trying to get at it. Right here, this will run. So this line right here ran. But once it hit the error, it like threw up this error and I couldn't do anything. This is not a good use case. I did the use cases before. Now I'm talking about implementation, just so we're getting clear on that. I would not use this as a good use case. I'm just showing you the syntax, how to implement a try catch. So if I know for some weird reason that I have code that could potentially throw an error. Okay. My prettier's not working anymore. Oh. There it is. Okay. So what this does, this is horrible program, like horrible coding, but it does what I want. What I want is I don't want my program to stop. I want my program to keep going. And this will allow me to have both lines run. Even though I know line 165 is going to throw an error, it did not stop my 168 from running. That's the point of try catch. It does not want to stop my program. Now I said it's bad because what we want to do is we want to be able to display in a log in a log file what's going on here. So to do that, I have to say pass in the error, and I'm going to throw in the error here. Now the problem here is it did run. If you see here, it said this will run, this will not run, but it throws this huge big thing in here, and usually we don't want this. So then we do something like either error.name, and it'll tell me the error, error message. It says input is not defined. So if I say error dot name something like this looks pretty good. That instead of having this stack trace, which is really good for debugging, it at least tells me there's an error. I'll clear this and run it again. It runs the line. It tells me the error name and this in a consolidated way, an easy to read way, and then it says, and then it keeps going. So the try catch does this. The other thing you can do, so this goes into, I'm gonna segue this into how I've done it before. I'm not gonna get to that. Okay. So they asked me on my old team, we had a service that sat in between 3 services. Anytime one of the services would update, we do health record information. So I'm going to simplify exactly what it did, but just go along with health records. Anytime a patient changed their phone number, that phone number needed to be synced between all systems. But you're talking about, millions of lines of codes being ran all the time. So what we did was we created a service, and of course I'm oversimplifying what it does. It's not really phone number, it does other stuff than that. But let's say that they changed their phone number. This service would pick up that change. It would create a payload with all of their information. So it would go grab their phone number from our system, the address from their billing system, their doctor information from their doctor system. It would compile that payload and ship it off to all of the systems so that all of them are now in sync. So all it did was it synced all the stuff together. What we did, let's say that we were going to send information to their doctor's office, but they really didn't have a doctor. We didn't care about it. At first, it would throw an error, and it would stop our program. So then what did we do? Well, we did this try catch thing. Well, if there's some error, just log that it's an error, but we don't want to stop the next message from going. We want all of these messages to keep flowing. So then so they had that already set up. What I had to do was I had to figure out, let's say that the doctor service to get the doctor message, it wasn't that that they didn't have a doctor, it's that service was down at that time. So I sent a message to the doctor service. The doctor service said the doctor service just wasn't even available. Well, what would that do to my system? Well, it didn't know what to do. So because of this try catch, it would just keep going. But at some point I said, whoa, if it doesn't even get an answer from the service, I need you to try that service again. So what I did was when I got an error from the service, I actually logged what type of error that was. And then I did a catch, and I did something similar to this, where I said, if error dot, and of course it's not, it'd be type technically. So I did something similar to this in my system where I actually got the actual error name, not the name, actually the type that it was going. And I had some other checks in there off of the error, like did it have this in it or blah, blah, blah. And then what I did was I did another error. And of course, this was also, so just remember, I was in a very complicated system where we had a try catch inside of a try catch. And so then I could throw this error and look for this error downstream and then actually handle it the way that I wanted to. And I actually resent the request. So I was able to reroute, like when you hit here, if it's a normal error, just keep going. We don't care about you. But if it's this very specific error, let's do something else. And so I could throw a new error that gave me more information and then handle it somewhere else. I could also, for this case, so this one, I'm going to clear this and write it again. So it says here, it goes through, it tries to ask a question and throws an error. Because the error name is reference error, and I grabbed that before, it actually runs this thing on the inside. If I thought it was a type error, it did not write that it liked those errors. So now I can start handling these errors even based off the type that they are to maybe reroute, or I can say, if it's a type error, go do go call this other function. So I could actually call a separate function anytime I got that error. Yeah, you can throw an error wherever you want to. You're right, though. If I throw it here, I have to catch it somewhere else. So just be careful. If you throw an error in the catch, it won't catch it as it's catching. So you got to catch it somewhere else. I don't know if that helped or hurt explanations. I was going to potentially go through class, but I think you guys deserve a long break before studio. The only other thing I was going to potentially do, I'm trying to come up with a running list of jobs that are like adjacent to software engineering that's not software engineering. So any last minute questions, and I'll stop the recording.